Welcome to lab. Today we're going to be looking at density and data analysis. So essentially, we're going to figure out which piece of glassware in the lab is the most accurate and precise. And in order to do that, we're going to figure out which of them gives us the density of water closest to the actual density of water. So our first piece of equipment that we're going to be working with is a beaker. This is a 50 milliliter beaker. You can see that it has various graduation lines on it, but it only goes up to 40 on the lines. So we're only going to measure up to 40 milliliters in this beaker. So I have here my semi-analytical balance. We're going to turn that on. And we're going to start by just getting the weight of the beaker by itself. So make sure that you record that the beaker by itself is 30.24 grams. 30.24 grams. And remember, we always want to give as many digits as are on the instrument itself. So this instrument gives 2 decimal places, so that's what we're going to do, 30.24. Now we have our distilled water, and we're going to fill up to our 10 milliliter mark, telling us that we've filled 10 milliliters of water. So I'm going to turn this around to face me so that I can get eye level with it and make sure that my water is stopping right at that 10 milliliter line. Okay, we are right on the line. So now we get our new mass, which is of 10 milliliters of water plus the beaker. So our mass now is 39.38 grams. 39.38 grams. So what we can do to figure out the mass of just the water is take this mass and subtract the mass of the empty beaker that we got previously. That will give us the mass of solely the water, which we're going to be using in our Excel spreadsheet. So now that I have my 10 milliliters, I'm going to add another 10 and go up to my 20 milliliter line. Okay, at 20 milliliters, our balance says 49.31 grams. 49.31 grams. 49.31. Go up to 30 milliliters. Now we are at 60.66. 60.66 grams. And for our last 10 milliliters to get us to 40 milliliters total, our last mass here is 70.24 grams. 70.24 grams. So for each of those masses with the water, we're going to subtract the mass of the empty beaker so that we can get the mass of just the water. The mass of just the water is what you're going to put into your Excel spreadsheet for later data analysis. Now we're going to try out our second piece of equipment, which is the graduated cylinder. So here we have a 50 milliliter graduated cylinder. You can see that it's 50 milliliters and it has lines going all the way through. Again, those are called graduations, why this is called a graduated cylinder. So we're going to start off by just getting the mass of the graduated cylinder empty. So the empty graduated cylinder is 95.87 grams. 95.87 grams. So we're going to start off by adding 10 milliliters. So we find our 10 milliliter line on our graduated cylinder, and we're going to fill up. Now remember that in a graduated cylinder, since it's a thinner tube, we create a meniscus. So we want to make sure that we're reading from the bottom of the meniscus, being right on that 10 milliliter line. And there we go. So our new mass is 105.91. 105.91 grams. So again, we can take the mass of the empty graduated cylinder and subtract from this mass to find out the mass of just the water in our cylinder. Let's go up to 20 milliliters. Again, find the bottom of the meniscus. And our new mass is 115.90. 115.90 grams. Let's go up to 30. Okay. For 30 milliliters, we're at 125.58. 125.58. We're going to go up to 40 milliliters. Okay. And our new mass is 135.55. 135.55. Now we're going to add our last 10 milliliters to take us to 50. Our last measurement for the graduated cylinder is 145.88 grams. 145.88 grams. So we now have our information for the beaker and our information for the graduated cylinder. Next up, we're going to look at the graduated pipette. Now we're going to look at our graduated pipette. This is a pipette, and you can see that it has the graduation lines on it. However, this is a 25 milliliter graduated pipette. We don't want 25 milliliters, we want 10 milliliters. So the way the graduated pipette works is kind of backwards, as you saw in the pre-lab video. So what we're going to do is fill up to the 15 line, because 15 down to 25 is 10 milliliters. So that's what we're going to do here. We're going to use our red pipette aid, so we're just going to put that on top. And I have a beaker filled with water because we never want to put a pipette directly into our source of an ingredient. This could possibly lead to contamination of the entire bottle if this pipette is contaminated with something. So I have a new clean 50 milliliter beaker that we're going to be transferring our 10 milliliters into. So start off by finding the mass of just that beaker. And that beaker is 28.52 grams. 28.52 grams. Let's take our first 10 milliliters. So we fill to the 15 milliliter line. Again, double check your meniscus and get it up to eye level to make sure that you are right on that mark. Take it over and we can release. So we've just added 10 milliliters of water using our graduated pipette. Our new mass is 38.39 grams. 38.39 grams. Let's add our second. Again, we go up to 15. Make sure the bottom of the meniscus is right on the line. And our new mass is 48.31. 48.31 grams. Let's get our third. Okay, our third measurement is 58.16. 58.16 grams. This is going to be now 40 milliliters total. That takes us to 67.95 grams. 67.95 grams. And now our last one. Our last 10 milliliters to take us to 50 milliliters total. Okay, and our final mass after 50 milliliters is 77.77 grams. 77.77 grams. So we've dried out our beaker so that we can use it for our next piece of equipment. Let's figure out if the mass changed at all. Our mass here is 28.51 grams. 28.51 grams of our empty beaker. This time, we're going to use a volumetric pipette. This looks different from what we just used because we see that we have this bulb here, and there's also only one line that we can measure. Hence, volumetric instead of graduated, because we can't go at various points. There's only one volume that this will hold. We're going to use a green pipette aid this time. And again, we're going to use a beaker filled with our distilled water rather than put it directly into our container. So we're going to fill up to the line. Again, being aware of the meniscus. Looks good. All right. And our mass is 38.47 grams. 38.47 grams after adding in 10 milliliters of water. Let's add in our second 10. All right. After our second addition, our mass is 48.39 grams. 48.39 grams. So after this addition, we'll have added 30 milliliters total. Okay. That takes us to 58.38 grams. 58.38 grams. This will take us to 40 milliliters total. Okay. After 40 milliliters, our mass is 68.33 grams. 68.33 grams. And we have one more addition of 10 milliliters to go. All right, for our last data point, utilizing the volumetric pipette, our mass is 78.26 grams. 78.26 grams. Let's move on to our final piece of equipment. Our final piece of equipment is the burette. The burette looks very similar to a graduated pipette, but it has a stopcock at the bottom. This stopcock helps us control when the water is coming out. So when the stopcock is vertical, that means that the burette is open, water will flow through. When it is horizontal, it is closed, the water will stop. A great thing about the burette is that this burette already has 50 milliliter markings on it. So we can fill the entire burette and then just release by 10 milliliter increments. However, in order to use a burette, we need a ring stand, and we need a burette clamp, which looks like this. So what we're going to do is put our burette in the clamp. We do that by going on the side, like so. Make sure it's in the grooves and that it's standing perfectly straight up and down. And we have our water that we can pour into the burette. So we're going to close the burette, make sure that we don't pour or that nothing falls through. And we're going to pour in the water that we're going to utilize. Like all of our glassware so far, we want to be eye level with it so that we can make sure the meniscus is right where it needs to be. So right now our meniscus, the bottom of it, is directly where it says 0.00 milliliters. The bottom here is where it says 50. this up a little bit. We have here our empty beaker that we have dried off, but let's double check the mass again. The mass of the empty beaker is 28.52 grams. 28.52 grams. So we are going to take our beaker and put it underneath our burette. And we're going to open our stopcock and add until we get down to where it says 10 milliliters. So I'm going to move this down just a little bit. Again, I want to be as close to eye level as I can. We're going to open the stopcock and we're going to bring it down and release the water until it takes us to the 10 milliliter mark. So we're going from the 0 line to the 10 line. Make sure you're at eye level with the 10 milliliter line. And we're going to do our very best to get the bottom of the meniscus on that line. All right, there's our 10 milliliters. So let's put this back on our scale. And the mass of our first 10 milliliters is 38.29 grams. 38.29 grams. Let's do that again. So now that we're on the 10 milliliter line, we're going to drop down until we hit the 20 milliliter line. So make sure you're at eye level with the 20 mark. And there we go. Let's get the mass. 48.26 grams. 48.26 grams. Now we're going to go from the 20 milliliter line down to the 30 milliliter line. Going to get eye level with the 30 line. Go. Check out our mass. The mass is 58.21 grams. 58.21 grams. Now we're going to go from the 30 line to the 40 line. I'm going to raise my burette up just a little bit so that it's easier for me to get eye level. And here we go. All right, there we go, 40 milliliters. The mass is 68.23 grams. 68.23 grams. So our last one, I don't want to put my burette too high or else it could cause some splashing. So I'm just going to go down, look at the 50 milliliter line, and make sure that that's where the meniscus stops. and we stop at the 50 line. So we've now added 50 milliliters of water, and our final mass is 78.22 grams. 78.22 grams. So we have now used all 5 different pieces of equipment in 10 milliliter increments. What we're going to do is subtract the mass of all of the empty containers, whether it was a beaker or a graduated cylinder, so that we get the mass of just the water at each different increment. Again, the mass of the water is what you're going to put in the Excel data sheet. We are going to analyze that information in the next lab. But to finish off today, we're going to look a little bit more conceptually at density, whereas this portion deals a little bit more mathematically with density. For part 2 of this lab, we're going to create a density column using some household items. I have here a 100 milliliter graduated cylinder. We're going to start off with our most dense substance, because the higher the density is, the more it will sink. The lower the density, the more it will float. So our first thing is going to be corn syrup. And we're just going to add roughly 20 milliliters. It doesn't have to be perfect. We just want to get a nice layer so that we can compare later. Okay, there's our corn syrup. Our next layer is going to be shampoo. So we should see that the shampoo just goes right on top of the corn syrup. Again, we're going to add roughly 20 milliliters. Doesn't have to be perfect. We just want to be able to see a distinct layer. Next up is dish soap. Our next one is colored water. This one can get a little bit messy because we're putting water on top of soap, so we can create some bubbles depending on how hard we pour the water on top. So we're going to try our best to not create too many bubbles, but sometimes it just happens inevitably. Oops. Did a little spill, but that's why we have the paper towel here. Okay, so not too many bubbles. We did all right. Luckily, it was just the water that spilled. And then for our last household item, we're going to add some vegetable oil. Okay, so it mixed with the water a little bit at first, and then it starts separating out. So we have our 5 distinct layers. Again, most dense at the bottom, and as we work our way up, we get to the least dense. What we're going to do now is take some different items, and we're going to put them or drop them into our density column. From there, we can figure out roughly what the density of these various pieces are. So go ahead and look at your procedure, and I want you to take a guess or make a hypothesis of where the various items are going to land. Let's see if your hypotheses are correct. So we're going to start off with a little pebble or a tiny rock. Drop that in. You can see it's making its way down. Slowly but surely. And it's now gone into the corn syrup layer. And there we go. Next, we're going to drop a paper clip. Let's see what happens with this. So our paper clip is considerably slowing down in the right in between the shampoo and the dish soap. Now it's possible that over time it'll continue to sink, but for right now we're going to say that it landed in between the dish soap and the shampoo. Next up we have an aspirin tablet. So the aspirin is now in the dish soap. Again, slowing down. Looks like our dish soap and our shampoo have mixed a little bit. Which can give us slightly skewed results. But we'll say it's roughly the same as the paper clip. And our last is a piece of chalk. And then the chalk is pushing down on the aspirin and on the paper clip. So we can see it moved the aspirin kind of out of the way. So our chalk has a higher density than the aspirin does. So take note of where these pieces ended up and how long it took them to get there. That's it for part 2. Next week, or next lab, you're going to take a look at your data from part 1, and we're going to figure out which piece of equipment is the most accurate and which is the most precise.